Section 11.3, perimeter and area of similar figures. First, some vocab here. Regular polygons are equilateral, equiangular polygons. They look like, for instance, if I did a hexagon, I would do this and I would mark all the angles congruent and mark all the sides congruent. Okay, equiangular. And equilateral. Okay? But again, we need both there. Similar polygons are polygons with the congruent corresponding angles and proportional corresponding sides. Okay. So first of all, we have these kind of two major things here. Now when we compare areas of similar polygons, what we end up doing is that since area is two dimensions, if I have an AB ratio, then I'm going to have an A squared, B squared ratio of areas. So we're going to say that a length ratio is AB, and then the area ratio is A squared, B squared. Now remember, ratios can be written in kind of fraction form, so a lot of times we end up using this. Okay, so that gives us that. Now our first couple of problems here, using theorem 11.7, okay, the ratio of perimeters. Now perimeter, that's a length issue. So I have a length here at 8, a length here at 12. So I'm going to say, hey, I have 8 over 12 because they want it small to large. And that does reduce. We always try to reduce our ratios. That comes out to 3 over 2. Or 2 over 3, excuse me. Okay. Now continuing here, and again, this is all based on the fact that we have similar polygons, in this case triangles. Now the area ratio is going to be my length ratio, and I'm going to square it. So we square the numerator at the top, we square the denominator at the bottom, and we get 4 over 9. And so here are my two correct answers as far as a length ratio and an area ratio. Moving on, as we go ahead and do some sketching of two similar quadrilaterals with an area of 4 to 1. Well, if I go ahead and just make a little one like this, I know that my bigger one needs 4 of these. So I'm going to go ahead, I'm going to double my height, and I'm going to double my base. So if this was 1 and 2 units, whatever, this would be 2 and 4, and I would really have, I got 1 here and I got 4 of them here. Now if we take a look at our length ratios, they're going to be 2 to 1 for my length ratio, and then 4 to 1 for my area ratio. Now I like to call these LRAT and ARAT for area ratio and length ratio. Now these problems are kind of setting us up for a little bit deeper type of challenges here. We're talking about a perimeter of one figure and its area, and then the perimeter of another figure and its perimeter. And again, the key thing here, we do have similarity, okay? So we need to find the area ratio of ABCD's quadrilateral to EFGH's quadrilateral. So off to the side here, I'm going to go, I got ABC quadrilateral. It's got a perimeter of 16, and it has an area of 64. I don't know what kind of shape it is. It's just a quadrilateral. Now with E, F, G, H, you know the perimeter is 12, but its area is unknown at this time. Okay? So I'm going to use a little bit of my workspace to kind of set up this situation here. And now they're asking us to find the area ratio of the ABCD to EFGH, whereas I really don't have both areas. So I'm going to have to use the perimeter, which is a length. So I'm going to take 16 over 12, that is my length ratio. I'm going to reduce it because they have a common factor of 4. And then I'm going to change it to an area ratio by squaring respectively the numerator and denominator. So I get a 16 over 9 is my area ratio. So part 1 is complete, and now I'm going to go ahead and find the area of the EFGH quadrilateral here. So I'm going to take my area ratio, and I'm going to take the corresponding area, and I'm going to call this area of EFGH, use some subscripting there. And then we're going to go ahead and do our previous proportion work where our teacher approved shortcut. I'm going to multiply those guys and divide by this. And so I'm going to get the area of this particular figure is going to come out to be 36 feet, and it's squared because it is in fact area. So here is my second answer. So as you see here, we're just starting with length ratios, which we've done in the past, and now we're applying them to a two-dimensional situation here. We're going to do a few problems here on the back side. We won't do them all. Okay, so taking a look here at A3 here, the ratio of two similar figures is given. Write the requested ratio. So this is an area ratio. I want a length, sides of length. So I'm going to root and root. So I'm going to get 7 to 5, and I am done with this problem. Alrighty. B here, I've got ratio of sides, so I'm going from length to area. So to do that, I have to square both. And so I'm going to get 9 to 16, or 64, excuse me. So that's my answer here. I'll let you do C on your own, and you can kind of check that next time you get a chance to check the answer key here. Now continuing here, just a couple minutes left here. We'll do one of these. Let's go ahead here, and we're going to do B. We have similar figures. Again, I'm trying to find this, which is right here. It's XY, corresponds with 10. Those are lengths. Have 198, goes with 108, or just 88, excuse me. So I've got this. Now I could square my lengths and then solve for XY, or I could root my numeric ones and then go ahead and solve. I'm going to go that route. Calculator is kind of going to be used anyway, so I might as well just kind of keep it like this. So I go ahead and set up my work here, and when I do this, I get yx equals, surprisingly, exactly 15 in inches. Now it's not inches squared due to the fact that it's not a area answer here. Now we'll do the one more problem here. And again, we have some options here. I'm going to go ahead here and set up A5. We're talking about rhombuses John and Bear. Again, my first name is John, and I'm a Bear fan, sorry to say. Again, like we did with a previous problem, I'm going to go ahead and list what I know about the Bear rhombus. It's got a area of 28. The area formula is based on diagonals, and it says that the diagonals I do not know. Looks like that's something we'll be finding here. John, the other rhombus, which is similar to Bear, has no area. But again, the area formula does in fact use diagonals. So I'm going to go 25 and 14. I can figure out that area, and that comes out to be 175. And I do know each of the diagonals. I've already used them. And so now I've got probably two problems to do here. So to find D1, I'm going to use my area ratio and do its corresponding. I do not know D1 from the Bear one, but I do know D1 is 25 here. Now similarly, I'm going to use the same area ratio, and I'm going to use D2 over there for rhombus Bear. And in this case, I'm going to use 14. So now again, I have area ratios compared to length ratios. So I'm going to have to do a little modification here, or adjustment. And if I square root an area ratio, I get back to a length ratio level. So now we do our cross multiplying teacher-approved shortcut. We should get D1 for rhombus Bear. Comes out to be 10. And this is centimeters. And for D2, doing the cross product work, we get 5.6. Decimals are allowable. Sorry about that, getting jumped on me there. So decimals are allowable to get for answers here. Well, that concludes the classroom portion. And again, one of your things we're going to have you do the rest of the period is to wrap up the few problems that we didn't do. Thank you for your attention.